Hi, I'm Lee Teschler from EE World and Design World. I'm here with Dan Carnavale from Eaton's Experience Center in Pittsburgh. It's quite often said that variable frequency drives save you a lot of energy, and we have a demonstration behind us that'll show just exactly how much when you're talking about moving air around. So Dan, take us through exactly what this is going to show us.
Thanks, Lee. Yeah, so when we talk about drives, we give the analogy of if you left your driveway in the morning and you put your foot all the way to the floor and you drove with your foot on the accelerator all to the floor and you wanted to slow down, you use the brake to slow down. And that wouldn't be very efficient. We normally would leave our foot off the accelerator. So a variable frequency drive, basically what it does is it adjusts the speed of the motor to the right speed instead of using a damper, in this case for airflow, or in the case of water flow, a valve. So instead of pumping all the way full pressure, full power against a closed damper or closed valve, then we can use a variable frequency drive, and it saves a lot of energy.
So Dan, why don't you quantify for us what the amount of energy savings might be in a situation like this?
Sure, Lee. So basically, if you think about an induction motor runs at 60 hertz, it's going to run at its full rotational speed. If you cut that speed in half, you run the drive at 30 hertz, for example, it's going to run at half speed. Now you might think you're going to save half the energy, but in fact you save almost more than that, more than 3/4 of the energy. You use a half times a half times a half, or about an eighth of the energy. So if you took a 100 kilowatt load, you'd use about 12.5 kilowatts to do that same amount of work. So that's the advantage of using the drive versus the valves and dampers.
Yeah, that's a significant savings.
It is, absolutely. And we're also going to show another feature that basically is where you take a drive with optimized control, and it actually uses even less energy. And I'll talk a little bit about that and how it works using that optimized control within the drive. So in the first case, I would turn on this starter, which is an across the line starter, and it's going to cause these ping pong balls in here to bounce around, and we're going to see a certain amount of airflow. And what I'm going to do is I'm going to put a damper on that to show that I don't like the flow that's coming out right now, and I'm going to cause this damper to change the flow rate of that air. And what you'll see is on the screen here, we're going to use almost the same amount of power. We're using about 1,000 watts, somewhere between 900 and 1,000 watts to do that work, whether I have the damper on there or whether it's kind of free flow. So again, it's like driving with your foot on the gas all the way to the floor and controlling your speed with the brake. So now what I'm going to do is I'm going to start this drive, and you'll notice that as the ping pong balls are bouncing around in there, I could adjust the speed to make it whatever it needs to be. And if I want to, I could try to match that with the ping pong balls over here bouncing around. And basically, when I do that, you'll see that I'm only using about 1/4 or less of the energy to do the work on the drive as I am with the damper on the airflow system here. So it's very clear that basically using the reduced speed on the drive saves a significant amount of energy compared to the damper on the ping pong balls on this side. So for the third demonstration, I'm going to compare two drives. One of the drives is a standard drive, and one of the drives has an optimized energy control. And in the 50s or so, there was a topic with this NOLA study where basically they found that in an induction motor, if you reduce the voltage just slightly, a little bit at a time, you can actually still get the same amount of work out of it, but reduce the power into the induction motor. And so that's what this drive takes advantage of. And we'll get a 5 to 10% energy savings with optimizing the energy flow, especially with this air handling system.